Welcome to my algebra class. We're on chapter 9, section 3. We're going to be solving word problems that using a system of equations, and we're going to use two different variables. We're going to let the two unknowns in the problem be represented by two different variables and then use the system and solve it. In this example, John has 15 coins, all dimes and quarters, worth $2.55. And the question is, how many dimes and how many quarters does he have? I'm going to let D equal the number of dimes and Q equals the number of quarters. So one equation I could come up with is D plus Q, the number of dimes and the number of quarters equals 15. The other equation comes from the value of the coins. Each dime is worth 10, so 10D is the total value of the dimes. And each quarter is worth 25, so 25Q is the total value of the quarters. So if I add 10D plus 25Q, I get 255 cents. I'm going to take the first equation and solve it here because I don't have a coefficient or number in front of either one of these except one. So I'm going to choose to solve for D. D equals 15 minus Q, substituted into this equation. So 10 times the quantity 15 minus Q plus 25Q equals 255. Multiplying using the distributive property, get 150 minus 10Q plus 25Q equals 255. Collecting like terms, I get 150 plus 15Q, negative 10 and 25, equals 255. Now solve for Q. Subtract 150 from both sides. I get 15Q equals 105. Divide by 15, and Q equals 7, so there are 7 quarters. Taking that 7, putting it back into the equation with the dimes, D equals 15 minus the number of quarters. 15 minus 7 is 8. So I have 8 dimes and 7 quarters. With that example, we're going to go do the evens from the page 424 assignment. So have your paper headed. Skip a line, and the assignment, I'm going to change it. It's going to be 424 written 1 to 10. And the directions on 424 say to go back and do 3 through 12 for 1 through 10. So number 3 is going to be number 1, so number 4 will be number 2. So number 2, let's change this around here. Number 2 is number 4 of the oral exercises. It says Kelly has 24 dimes and quarters worth $3.60. How many quarters does she have? So if I let D equal the number of dimes and Q equal the number of quarters, then I can write the equation D plus Q equals 24. And they tell us that the coins have a value of $3.60. The total value of the dimes would be 10D, and the total value of the quarters would be 25Q. So I could write the equation 10D plus 25Q equals 360 cents. I'm going to solve for D over here. Doesn't matter which one you choose. So D equals 24 minus Q, and then I'm going to substitute in where I see D. So I have 10 times the quantity 24 minus Q plus 25Q equals 360. Using the distributive property, we get 240 minus 10Q plus 25Q equals 360. Collecting like terms, we get 240 plus 15Q equals 360. Solve for Q, undo addition, subtract 240. We get 15Q equals 120. Divide by 15, and we get 8. So there are 8 quarters. And to find the number of dimes, we take 24 minus the quarters, and that would be 16. But they only wanted to know the number of quarters, so we don't need to worry about the dimes. So this is our answer. There are 8 quarters. Problem number 4 would be number 6. It says Louise and Julia have the same number of coins. Louise has only dimes and Julia has only quarters. If Julia has $1.80 more than Louis does, how many coins does each have? So they have dimes and they have quarters. So D equals the number of dimes. And Q equals the number of quarters. And they said, and remember the dimes were what Louise has, and Julia has the quarters. They said they have the same number of coins, so D equals Q. And then it says Julia has, the value of the dimes would be, of course, 10D, and the value of the quarters would be 25Q. And it says Julia has $1.80. Now remember, Julia has the quarters, so she has 25Q. Has $1.80 more than Louise does, so she has 180 cents more than, 180 plus Louise' amount, which is 10D. So they've already solved the equation for one variable here, so we'll just plug it in. And I can go ahead and I'll just say D equals Q. So 25Q equals 180 plus 10Q. Subtracting 10Q from both sides, we get 15Q equals 180. Divide by 15. We get Q equals 15 goes in 18 once and in the 30 twice. So there are 12 quarters. And that would be the number of coins for Julia. Which is also the number of coins for Louise. Problem number 6 would be number 8 on the oral exercises. It says Annette and June bowled together and had a combined score of 425. June's score was 25 less than Annette's score. Find their scores. So if we let X equal Annette's score, and Y equal June's score. From the first part of the sentence, it said they bowled together and had a combined score of 425. So X plus Y equals 425. Then they also have a second sentence that says that June's score, which is Y, is 25 less than Annette's. So X minus 25. And looking at these two equations, I can see I would use this first, since it's already solved for one variable. Substitute it in over here. So we have, for Y, so we have X plus X minus 25 equals 425. Collecting like terms, 2X minus 25 equals 425. Solving for X, we would add 25 first to both sides. And we get 2X is 450. Divide by 2, and X equals 225. So Annette's score would be 225. And plugging that back in here to find June's score, hers would be 225 minus 25 equals 200. So y equals 200, which is June's score. That was problem number 6, which was 8. Problem number 8 would be number 10 on the oral exercises. Number 10 says the length of a rectangle is 5 centimeters. Less than 3 times its width. If the perimeter is 70, find the dimensions. So if we use W for the width, then the length of the rectangle is 5 centimeters less than the width, than 3 times the width, excuse me. So 3W minus, oops, we got to use different variables. And this is L. So the length is 5 less than 3 times the width. So length equals 3W minus 5. And then it says the perimeter is 70. Well, remember I like to use half the perimeter, which is length plus width. So length plus width will equal 35. Half the perimeter, half of 70 is 35. So I have my 2 equations, and this one here is solved for L, so I'll substitute it in here. So 3W plus, minus 5 plus W equals 35. Collecting like terms, 2W minus 5 equals 35. Solving for W, add 5 to both sides. I get 2W equals 40. Divide by 2, and the width is 20. And substituting that back in here, the length is 3 times 20. Take away 5. So that would be 60 minus 5, which is 55. And we're done. So the length is 55 and the width is 25. Problem number 10, which is number 12 in the oral exercises. It says a person invests $5,000 in treasury notes and bonds. The notes pay 8% annual interest and the bonds pay 10% annual interest. If the annual income is $480, how much is invested in treasury notes? Well, we'll let X equal amount invested in treasury notes. And Y can be the amount invested in bonds. And it says that the total investment was 5,000, so X plus Y equals 5,000. And then they say the notes pay 8%, so 0.08X is the interest for the notes. And the bonds pay 10%, so 0.1Y equals the interest for the bonds. So if I take 0.08X and add it to 0.1Y, I will get the total annual income of interest of $480. I'm going to move the decimal points over in this second problem, so this is, I'm moving it over 2. Over 2 would be 10Y, and over 2 would add 2 zeros. I'm going to solve for X over here, so we get 5,000 minus Y. Substituting it in for X here, 8 times 5,000 minus Y plus 10Y equals 48,000. Distributive property gives me 40,000 minus 8Y plus 10Y equals 48,000. Collecting like terms, negative 8y and 10y make 2y. Solving for y, subtract the 40,000 from both sides. And I get 2y equals 8,000. Divide by 2, and y equals 4,000. So there was $4,000 invested in bonds. Putting that back up here into this equation, 5,000 minus 4,000, there was $1,000 invested in notes. And I think we only wanted to know on that one how much money was invested in the notes. So here's our answer. That concludes the evens. Be sure and check the back of the book for the answers to the odds as you do them.